Hello dear students, welcome to YouTube channel Learn with Gisela. In this video of number systems, we are going to learn conversion of decimals into the form of p by q. Now we know that the decimal form of only rational numbers can be written in the form of p by q, and decimal form of rational numbers can either be terminating or non-terminating but recurring. So accordingly, we are going to learn the conversion of each type of decimal form, that is terminating as well as non-terminating. So let's start. Now first of all, let us start with conversion of terminating decimals into the form of p by q. Let us take up a question to understand it. Convert terminating decimal numbers into the form of p by q. Now there are four parts to this question, and each part contains terminating decimal number which we have to convert into the form of p by q. That means we have to write in the form of a rational number of the form p by q. Now first part is 0.35. So 0.35 has two decimal places. So in the denominator we will have 100. So we shall write 35 by 100, and further we can simplify by dividing by 5 both the numerator as well as denominator, and we shall get 7 by 20 as the p by q form. Now second part is 0.175. Now there are three decimal places. So in the denominator we shall get 1000. So 175 upon 1000. Further we can simplify by dividing by the common factor, which is 25. So 175 will be divided by 25. We shall get 7. 1000 divided by 25 we shall get 40. So 7 by 40 is the p by q form of a rational number, right? Now the third part is 0.0025. Now there are four decimal places. So in the denominator we shall write 10,000, and in the numerator we shall write 25. That means without the decimal point we shall write the numerator. 25 and 10,000, the common factor is 25. So we shall divide numerator and denominator by 25 and get the p by q form of a rational number, that is 1 by 400. Now fourth part is 8.0025. Now there are four decimal places again. So in the denominator we shall have 10,000. In the numerator we will have the number without the decimal point, that is 80025. Now the common factor is 25. So we shall divide numerator and denominator. So we shall get 3201 upon 400. So this is also a p by q form of the rational number. So this is how we convert terminating decimals into the form of p by q. Now let us further understand the conversion of non-terminating repeating decimals into the form of p by q. Now there are two types of non-terminating repeating decimals. One is pure recurring decimals and other is mixed recurring decimal. We have to understand both of them because the conversion of both of them is different. Now what are pure recurring decimals? A decimal number in which all the digits after the decimal point are repeated. For example, say 0.7 bar. In this, after the decimal point we have 7, which is repeated. Then we have 0.32 bar. Under the bar we have 32. So 32 is repeated. Then we have 0.675 under the bar. So 675 is repeated. That means there is no other number which is not repeated after the decimal point. So such decimal numbers are known as pure recurring decimals. Now what is mixed recurring decimal? A decimal number in which at least one digit after the decimal point is not repeated and others are repeated. That means at least one should not be repeated. So those decimals are known as mixed recurring decimals. For example, 0.72 bar. Now under the bar we have only 2, 7 is not repeated. Then 0.645, 45 is under the bar, 6 is not repeated over here, whereas 45 is repeated. Then we have 2.1275, 75 is under the bar, that is repeated, but 12 is not repeated. So a decimal number in which at least one of the digit after the decimal point is not repeated while other digits are repeated, those are known as mixed recurring decimals, right? Now let us study about their conversion. Now these are the 6 questions which we are going to take up in this video. These all are related to converting non-terminating repeating decimals into the form of P by Q. And because it is non-terminating and repeating, you can observe there is a bar on every question. Right? And question number 1 to 4 are related to pure recurring decimals because every digit after the decimal point is repeating. Whereas question number 5 and 6 is related to mixed recurring decimal because there are two digits which are not repeated, like 25 is not repeated over here, 12 is not repeated. So these question number 5 and 6 are related to mixed recurring decimals. Question number 1 to 4 are related to pure recurring decimals. Now let us start with each question. Question 1 is express 0.7 bar in the form of P by Q where P, Q are integers and Q is not equal to 0. So there are two methods to solve this question. Let us start with the first method. Let x is equal to 0.7 bar, or we can also write 0.7777 so on because 7 is being repeated. This is our equation 1. Now since there is only one repeating digit, that is 7, after the decimal point, we shall multiply both the sides of equation 1 by 10. Now equation 1 is x is equal to 0.77. So both the sides, on left hand side we will write 10x, on the right hand side we will write 10 into 0.777 so on, and that is equal to 7.7777 so on. This is our equation 2. Now 10x is more than x. So we will subtract 1 from 2, that is first equation, from the second equation, and we get 10x minus x is equal to 7.777 so on minus 0.777 so on. So 10x minus x is 9x, 7.77 minus 0.77 we will get 7.00, and further 7.00 is nothing but 7 only, so 9x is equal to 7, so we can say x is equal to 7 by 9. And what was x? X we had assumed 0.7 bar, so 0.7 bar is equal to 7 by 9, right? So here we have used the first method to solve 0.7 bar and convert it into the form of P by Q. Let us now learn the second method. Now the second method is the rule method, and the rule for conversion of pure recurring decimal is write the given number after removing decimal as the numerator. That means you have to write in the numerator the given number without the decimal point, and in the denominator write down as many nines as the number of repeating digits after the decimal point. So you have to count the number of repeating digits after the decimal point, and that many nines you are going to keep in the denominator. So like our question was 0.7 bar, which we can write equal to 7 by 9. Why? Because write 7 in the numerator, because without decimal point we will write 7 in the numerator, and 1 9 in the denominator, as only one repeating digit, that is 7, is after the decimal point. So in the numerator you have to write the given number as it is without the decimal point, and in the denominator you have to write as many nines as the number of repeating digits after the decimal point. So our answer in the form of P by Q is 7 by 9. Now let us take up second question. Express 0.23 under the bar in the form of P by Q where P, Q are integers and Q is not equal to 0. Now let us start with the first method, where we shall assume let x is equal to 0.23 under the bar. Since 23 are the two digits which are going to be repeated after the decimal point, so we can write 0.232323 and so on. So this is our first equation, x is equal to 0.2323 and so on. Since we have two repeating digits, that is 23, after the decimal point, so we shall multiply both the sides of equation 1 by 100. So we shall write 100x is equal to 100 into 0.2323 so on is equal to 23.2323. So this is our equation 2. So first equation is x is equal to 0.232323 and second equation is 100x is equal to 23.232323. Now we shall subtract 1 from 2 and we shall get 100x minus x is equal to 23.2323 minus 0.2323. Since second equation is greater than first equation, so we have subtracted the first from the second equation. Now 100x minus x is 99x. 23.2323 minus 0.2323. So all the decimal points basically will get cancelled and we are left with 23.000, which is nothing but 23. So we can write 99x is equal to 23. Further we can say x is equal to 23 by 99. And what was x? X was 0.23 bar. So 0.23 bar we can say it is equal to 23 by 99. So this is the p by q form of the decimal number. Right? Now according to the second method, that is by rule method, we can say that write 23 in the numerator and 99 in the denominator, because there are two repeating digits, that is 23 after the decimal point. So 0.23 bar, just remove the decimal point, write down the numerator 23 and below it in the denominator write down 99, because there are two repeating digits after the decimal point. Right? Answer is same, 23 by 99, 23 by 99. Both the methods, first is where we are assuming x to be equal to the decimal number, and second method is by the rule method. Both methods will give you the same answer, right? Now let us take up third question. Express 0.437 under bar in the form of p by q, where p and q are integers and q is not equal to 0. Now let us start with the first method. We shall assume let x is equal to 0.437 under the bar. Since under the bar we have three digits, so these three digits, that is 437, are going to get repeated. So 0.437, 437, 437. So this is our first equation where we say x is equal to 0.437, 437, 437 and so on. Since we have three repeating digits, that is 437 after the decimal point, so we shall multiply both the sides of equation 1 by 1000. So when we are going to multiply x by 1000, we are going to get 1000x, and 1000 into 0.437, 437 and so on, we shall get 437.437, 437. So this is our second equation. 1000x is equal to 437.437, 437. This is our second equation. Now 1000x is more than x. So we can say second equation is more than first equation. So we shall subtract the first from the second and we get 1000x minus x is equal to 437.437, minus 0.437437. Now 1000x minus x is 999x and 437.437 minus 0.43747. Basically all these decimal points are going to get 0 and we are left with 437.000, which is nothing but 437. So we can say 999x is equal to 437. So now cross multiply, x is equal to 437 by 999. And what was x? X was 0.437 under bar. So we can say 0.437 under bar is equal to 437 upon 999. So this is our p by q form of the decimal number 0.437 under bar. Now let us come to second method, that is by rule method. According to the rule method, we can say that we can write 437 in the numerator. That means without the decimal we can write 437 in the numerator and then 999 in the denominator, as there are three repeating digits, that is 437 after the decimal point. So the answer is 0.437 bar is equal to 437 divided by 999. This is our p by q form, and if you see, both the methods are giving the same answer, right? Now let us move to fourth question. Express 18.48 bar in the form of p by q, where p and q are integers and q is not equal to 0. Now let us solve it by first method. Let us assume let x is equal to 18.48 bar. Now under bar we have 48, that is 2 digits are there which are going to get repeated. So we can get 18.4848. This is our equation 1. X is equal to 18.4848. Now since we have two repeating digits, that is 48 after decimal point, we shall multiply both the sides of equation 1 by 100. So 100 into x on the left hand side we shall get 100x, and on the right hand side 100 into 18.4848 is equal to 1848.4848. This is our equation 2. Now equation 2 is greater than equation 1 because 100x is greater than x. So we shall subtract 1 from 2. We get 100x minus x is equal to 1848.4848 minus 18.4848. Now 100x minus x is 99x, and 1848.4848 minus 18.4848 we shall get 1830.000. Basically all the decimal digits will get cancelled and we shall get 00 after the decimal point, which is nothing but 1830. So we can say 99x is equal to 1830. Further, x is equal to 1830 upon 99 because we are going to cross multiply and get the value of x. Now what was x? X was 18.48 bar, which is equal to 1830 upon 99. So this is the P by Q form, 1830 upon 99, right? Now the second method is the rule method, under which the decimal number 18.48 bar can be split into two parts, 18 plus 0.48 bar, which is equal to 18 plus, now 0.48 bar is a pure recurring decimal which we will apply rule over here. That means write the numerator as it is, and in the denominator we shall write 99 because there are two digits which are going to be repeated after the decimal point. There is 4, there is 8. So that's why 48 by 99. Now take the LCM. 99 is the LCM. Further 99 into 18 plus 48, which is equal to 1782 plus 48 upon 99, which is equal to 1830 upon 99. So this is the, we can say, P by Q form of the decimal number 18.48 bar is equal to 1830 upon 99. And by the first method also we got the same number, 1830 upon 99, right? Now let us take a fifth question. Express 0.2562 bar in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now if you see this decimal number, it's a mixed recurring decimal number where 25 after the decimal point is not being repeated. So such decimal numbers are known as mixed recurring decimal numbers. Now questions 1 to 4, we had pure recurring decimals where we had applied two methods, first method and second method. First method we have assumed the decimal number to be x, and in the second method we had applied the rule method. Right. Now since over here it's a mixed recurring decimal, so we are going to combine both the methods and use them to solve this question. So let us start with assuming let x is equal to 0.2562 bar. Now since only two digits are being repeated, that is 62, we can write it as 0.25, 62, 62, 62 and so on. So this is our first equation. X is equal to 0.25626262. This is our first equation. Now we have two repeating digits, that is 62 after the decimal point. So we are going to multiply both the sides of equation 1 by 100. So 100 into x is 100x, and 100 into 0.256262 is nothing but 25.6262. And 62 is being repeated, so we can also write it as 25.62 bar. So this is our second equation. 100x is equal to 25.62 bar, right? Now 100x is equal to 25.62 bar, which we can split and write 25 plus 0.62 bar. Now this 0.62 bar has become a pure recurring decimal. So what we have done is basically from the mixed recurring decimal, we have converted it into a pure recurring decimal. 25 is as it is and 0.62 bar is a pure recurring decimal because all the digits after the decimal point are being repeated. Now we shall apply the rule method over here. So we shall write 100x is equal to 25 plus 62 upon 99. Why? Because 62 as it is in the numerator will come, and since two digits are being repeated after decimal point, so write down 99 in the denominator. Now take the LCM. 99 is the LCM. 99 into 25 plus 62, which is equal to 2475 plus 62 upon 99, which is equal to 2537 upon 99. Now further we can say 100x is equal to 2537 upon 99. So x is equal to 2537 upon 9900. Just cross multiply. So the value of x has come 2537 upon 9900. And what was x? X we had already assumed it to be 0.2562 bar, and the p by q form is 2537 upon 9900. Now let us move to sixth question. Now the sixth question is express 32.1235 under bar in the form of p by q where p and q are integers and q is not equal to 0. Now, if you observe this number is a mixed recurring decimal number because we have two digits after the decimal point, that is 1, 2, which is not going to get repeated. Only 35 is going to get repeated. So this is mixed recurring decimal. So we are going to combine both the methods, both the first and the second method, that is the assuming x and the rule method, both are combined to solve this question. So let's start by assuming x is equal to 32.1235 under bar. 35 is being repeated, so we can write 32.123535. So this is our first equation. X is equal to 32.123535. Now since two repeating digits we have after the decimal point, we shall multiply both the sides of equation 1 by 100. So 100 into x is 100x and 100 into 32.123535 is nothing but 3212.3535. Now since after decimal point 35 is being repeated, it can be put under the bar. So we can write 3212.35 bar. So this is our equation 2. Now if you observe this equation 2, that is 100x is equal to 3212.35 under the bar. Now this has become a pure recurring decimal, right? Because there is no digit after the decimal point which is not repeating. Every digit after the decimal point is repeating. 35 is being repeated. So now it has, from the mixed recurring decimal, it has turned into a pure recurring decimal. Now we shall apply the rule method. We shall split it into two parts, 3212 plus 0.35 bar, which is equal to, we can say 3212 plus 35 by 99. 35 write down as it is in the numerator and 99 we will write in the denominator because there are two repeating digits after the decimal point. So 35 by 99. Now take the LCM. 3212 into 99 plus 35 upon 99. Now 317988 plus 35 upon 99, which is equal to 318023 upon 99. So 100x is equal to 318023 upon 99. Cross multiply and get the value of x. X is equal to 318023 upon 9900. Now x is equal to 318023 upon 9900, and what was x? X was 32.1235 bar. So which is the p by q form of which is 318023 upon 9900, right? So with this we come to end of this video. Hope you have understood conversion of decimals into p by q form. Thank you everyone. Have a great day ahead.